complete detail. For that, they have created simple format. That simple format will give a good start towards the understanding the system requirement. Here you can see this, the simple format of the requirement. One is the name. Here they have to mention clearly about the product name. That give the names will give them project, not only simplifying talking about its other people, but can be give the crystal clear purpose. The next one is a purpose. They have to give clearly describe their product at least within the 2 line. It will support our design. If we can't describe the essence of the product or system in 1 or 2 lines, chances are that you can't understand well enough. So the customer, they have to tell clearly, or they have to describe clearly what is the purpose of the product. The next one is input and output. This very important. The input and output of the systems encompass the wealth of the details. That means what type of data, okay, what data characteristics, types of input output device, where we are getting data, whether it is analog electronic signal or digital signal or mechanical input, or the data characteristics is it is arriving periodically, or it's digital data or video data. Then types of I/O devices, we can say whether it is a button or analog and digital converter is there, or we are giving a output display, or only the sound. So these are all you have to collect from the customer. Then the function. This is more detailed description of the system. What you have to, if they said the requirement, this product I need, then you have to tell that what is the function will do, or the customer have to tell that what the product will do this function. So clear cut detail is need for this product. The next is performance. The performance is very important. Why? Most of the embedded systems are related with or controlling the physical devices or processing the data coming from the physical world. That is, most of our embedded systems are connected with outside world. Either it will control the physical device, or it is communicating to the physical world, or data collected from the physical world. So here performance play major role. It is essential that the performance requirements being identified early, because they must be very carefully measured during the implementation to ensure that the system work properly. You have how the system work properly based on the performance. The next one is the manufacturing cost. The manufacturing costs include your hardware component as well as your non-functional, non-recurring cost. Okay, so non-recurring cost you have to include for your manufacturing cost. Then the power. Similarly, you may have only a rough idea of how much power the system can consume, but little information will give longer way. The typical information or most important decision is whether the machine will work battery powered or plugged into the one, because the product may be a movable product or standalone. So based on that, you have to take the power. Then the physical size and weight. You should give some indication of the physical size. So this is the way you will get the product. Is it okay for whether this physical size fit into your system, or your product? You can tell that industry, that is which level size or how much weight you want. So when if you're told something, right, this will not, this is the size you will get it, this is the weight you will get it. This information you have to get the customer should tell all the details, then depends upon all this physical size, weight, power, manufacturing card, performance, function, output, input, purpose and name, then we can clearly design up their product. Let us take the recommend analysis of the GPS moving map. The moving map is handheld device that display for the users a map of the terrain around the user's current position. The map display changes as the user and the map device changes position. You can see this, the map moving obtained position from the GPS. It points map from the local data. How it will give the data either from the local database or through the satellite based navigation system. Here it will give the latitude and longitude, so you can find out the position. You can see in the GPS usage in the many devices, in a car and your mobiles. All this is you have seen this GPS system. So many of the applications they are using for they have placed their GPS in their suppose the child going somewhere else, they will place the GPS and they can monitor their grandparents through their GPS system. This is a very useful systems. Now we'll consider this GPS moving map recommend. Okay, here the what recommends might we have for our GPS moving map. So initially we have to start with the functionality. The system is designed for highway driving and similar uses, not nautical or aviation uses. Okay, recommends more specialized database and the functions. Then user interfaces. Here the user interfaces, the screen should have at least 400 into 600 pixel resolution. The device should be controlled by no more than 3 buttons. So this is the user interfaces. The menu system should top up the screen when the buttons are pressed to allow the user to make selection to the control systems. The performance, the map scroll smoothly. Okay, the display should take no more than the 1 second or to appear. And system should be verify its position and the display the current map within the 15 seconds. These are the performance. Cost, the selling cost, that is street price of the unit should be more than some dollar, $120. Physical size and weight, the device should fit comfortably in the palm of the hand. So this is the recommend. The power consumption, the device should run at least 8 hours on 4 AA battery with at least 30 minutes of those 8 hours comprising operation within the screen on. So these are the recommend of the GPS moving map. This is a way to collect the complete detail about your system or product. So as I told you that we need the we have to write the GPS moving map name, recommends functionality for automotive use, show major roads and landmarks, user interfaces at least 400 to 600 pixel screen, 3 buttons maximum, and performance, map should scroll smoothly, and upon power up the display should take more than 1 second to appear and lock on to the GPS within the 50 seconds, and the cost should be not more than $100, $120. And the physical size should fit in the palm of the hand. It just depends upon the customer recommend. And the power consumption, device should run for 8 hours on a AA batteries. So now we have to fill the recommends sheet, okay, format. What is the purpose of name? GPS moving map. Purpose, consumer grade moving map for driving. Inputs, power button, 2 control buttons. What is the output? Backlight LCD 400 into 600, and function 5 receiver GPS, 3 resolution, display the current location, latitude and longitude, and performance updates screen within, that is the speed, okay, updates screen within 0.25 seconds for the moment, and manufacturing card less than $100, okay, power 100 milliwatts, physical size and weight no more than 2 cross 6 cross 12. So next we'll see the specification. A more precise description of the systems should not imply a particular architecture and provide input to the architecture design process. It may include the functional and the non-functional element. The specification should be include the non-functional and non-functional element. May be executable or may be mathematical form of the proof. The specification may be an executable or may be a mathematical form of the proofs. So here the GPS specification. Data received from the GPS satellite constellation, map data, user interfaces, operation required to satisfy user request, background operation needed to keep the system running. These are the GPS specification. So what is the architecture design for your GPS? Designed to satisfy both functional and non-functional requirement. Here the hardware components are CPU, peripheral, etc. And similarly, software components are major program and their operation. Must take into account functional and non-functional specification. For the architecture design itself, we have to consider functional and non-functional specifications. So the architecture is a plan for the overall structure of the system that will be used later to design and the components that make up the architecture. Here we will see the block diagram. The block diagram shows the sample system architecture of our GPS method. Here it is not clearly specified what operation it will perform, whether it is performed, it will run by software on CPU or whether it is any special hardware is there. Just it gives the block diagram, right? The overall architecture of the GPS moving map system. Okay, so we can have the diagram does however go a long way towards describing how to implement the functional described in the specification. So we can clearly see, for example, suppose we need search some data, so we can say that cover a pattern, okay, and it render the result for the display. We have chosen to separate those functions so that we can potentially do them in a parallel way. So what I want to convey here is, this is a total block diagram. So we cannot, here there is no separate block diagram for hardware and software. So if you segregate with the hardware part and software part, then we can easily understand, and they have to work together, the hardware part and the software part. The team has to consider for the hardware part, work parallel along with the software developer, then only you will get a Paka product. So now you can see this hardware architecture. The hardware architecture clearly shows that display, frame buffer, and this is two memories that they are using, frame buffer and memory and CPU and the GPS receiver and IO devices, right? And similarly, software architecture, you can see the software architecture of this GPS moving map, that is position, database search, and user interfaces here. The timer may be a hardware timer or a software timer, and the render, and you will get the display. So designing hardware and software components must spend time in architecting the system before start coding. Some components are ready-made, some can be modified from the existing design, other must be designed for the scratch. So designing hardware and software depends. It may be ready-made or you have to start from the scratch. So now we have the teams are developing hardware part and the software part. Now you have to integrate these two, then only you will get the complete system. So put together, so system integration is very, very important. That means when you put together the hardware and software, definitely you find the bugs on at least any one of the stage. Okay, many bugs appear only at this stage in this case. Okay, so some software bugs you can rectify it. Okay, but if it is the bugs occur in the hardware part, then it is very difficult. Have a plan for integrating component to uncover bugs quickly. Test as much functionality as early as possible. And so finally, the summary of this embedded system: embedded computers are all around us. Many systems have complex embedded hardware and a software. So embedded system poses many design challenges